Okay, so my presentation is on heaps. It's a data structure used in computer science in many different languages, and this is what I did my research on for my final project for data structures. So with heaps, you start with a bigger they're all connected anyway. You start with a bigger topic called trees, and this is a data structure where you start with many different nodes that are connected in a parent-child formation. So you start with a singular node, and this becomes the parent node when it has two children, or it can have multiple children, but in this example it has two. And each node is called the child node, which refers back to the parent node. And you can keep going down all the way until many different nodes have occurred. In here you see a tree where there's a parent node with 3 different child nodes. And that doesn't really happen in heaps because heaps are part of a smaller set of trees called binary trees. So the kind of trees we're using is you have either 2 options with binary trees. You have either a left node or a right node that you're going to refer to, and when you put them together, you have your binary tree. This is where listen, all these topics are connected. So with binary trees, your parent node can only refer to either a left node or a right node in terms of what you can go next in the order for. But with heaps, it's not all binary trees are heaps. Heaps are actually a form of a binary tree that you bring in. And the way heaps work is that in order to classify everything in the correct order, we use iteration. We cycle through heaps over and over again, going in circles. You get it? Yeah, there you go. So if we pull that aside for a second, we see our key principles of heaps start out with size. That's at the forefront of our mind when we talk about heaps. And that's because heaps are really dependent on the size of the values that go in and how to order those sizes correctly. Before we talk about size, there's 2 different types of heaps that we have to think about. And in order to actually classify everything in the right size, you use the whole iteration principle. So the 2 different types of heaps are a min heap or a max heap, and that stands for minimum maximum. And the comparison, so the difference is that a minimum heap goes in increasing order from the parent node all the way down to the child nodes. So as you can see, every node only has up to 2 child nodes. However, the parent node is always less than or equal to either of its child nodes. In a max heap, it goes the other way around. The greatest value is at the top of the heap, and then it goes down to 1 of 2 nodes that are either less than or equal to in value. So here's an example of how a heap works. If we start with the input of these numbers, 35, 33, 42, so on, we start with the first number, which is 35, and then it checks to see whether 33 is less than 35, and then it keeps it. 42 is not less than 35, so it goes back up because this is a max heap, and all the maximum numbers have to be at the top. And it keeps going throughout in this little animation. So it keeps going to make sure that all the numbers below are less than the number above in the parent node, just to make sure that it maintains the heap principle for the maximum heap. And then it finally checks the last node, and then that's how we know our inputs have been classified in a max heap. The logic for a heap works like this. So in a max heap, first you start with creating a new node at the end of the heap, and then you assign a new value to the node. So in our case, we start with 35 and 33, and then we compare the value of this child node with its parent. If the value of the parent is less than the child, you implement some sort of swap function, and then you repeat steps 3 and 4 over and over until the heap property holds, which means every parent node is less than or equal, greater than or equal to the child node. And then with min heaps, it works the opposite way, except the same way, except the step 4 is the opposite. The value of the parent has to be more for it to be swapped. And this is what that code looks like. So the swap function is like this. You put in 2 different positions. Generally, this is in Java. And with these 2 positions, there's a temporary variable that holds the position of the first position heap value, and then the second position heap value takes on the value of the first position, and then the temporary variable goes in the second position. That's the swap function. The way it works is that, again, you compare the child node with the parent nodes, and then you keep going down until you see whether the child node is greater than or equal to the parent node, and if it is, then you just implement the swap function to make sure that the parent is always greater than the child. And that is the heap.
Should I stop it?
Yeah, please. All right.